Now, if we talk about purpose of embedded system, so the purpose of embedded system is to perform specific tasks or functions efficiently, reliably, and often in real time. They are integrated into larger systems to provide dedicated functionality. The purpose in details are as follows. Special functionality. So embedded systems are designed for specific tasks such as controlling a washing machine, managing car's engine, or monitoring a medical device like our pacemaker. Real-time operation. Many embedded systems operate in real time, responding to inputs and providing outputs within strict time constraints. This is essential in systems like airbag, pacemakers, and industrial automation. Embedded systems are to be optimized for performance so that it ensures speed and efficiency, and it should have compact size so that it fits within the constrained space, and its power consumption should be as low as possible because most of them are. Then it should have cost effectiveness, so its design should be using lesser number of resources, and of course it should be optimized for uh, meeting the functional requirement as well as the performance requirements. Then in automation and control, it should have enable automation by controlling processes without human intervention. Some examples include home automation systems, robotics, and smart appliances. It should be interfacing between hardware and software. They serve as a bridge between the physical hardware and the software, allowing devices to interact with the external environment, such as external environment means sensors, actuators, etc. And their applications in diverse fields uh, like consumer electronics, then in automotive, then in healthcare, industrial process, so on. If we talk about features of embedded system, then one of the important feature is real-time operation. So deterministic performance. Many embedded systems operate in real time, meaning they respond to inputs or events within a defined time frame. Examples: airbag system in car deploy within millisecond of detecting a crash. They are single function. They perform one task or a small set of related tasks repeatedly. For example, digital camera. Then low power consumption is another important feature of embedded system. They are mostly battery powered, so they should be consuming a very small amount of energy so that the time between charging can be elongated, and they should be having a compact size so that it can fit within the appliances. It should be high reliability. It is designed to work consistently and stably in critical and harsh environments with minimal chances of failure. Example: industrial automation system works for years under challenging conditions. Hardware software integration. Embedded systems tightly coupled hardware and software to optimize performance and functionality. Example: the firmware in a microwave oven directly controls the hardware to manage the heating function. Limited user interface. Many embedded systems have simpler or no user interface. For those with user interface, it is minimal and specific to task. For example, washing machine often have a simple UI with buttons or knobs. Resource constraints, so limited computing power, memory and storage compared to general purpose systems. Example, a thermostat uses a small processor and limited memory to control the temperature. Means the resources are very much optimized in order to enhance the cost. Some more features like application specific. So every embedded system is developed for certain applications, uh, and like example, automotive systems like ABS are specifically designed to enhance the vehicle safety. Embedded embedded in larger systems, especially often a subsystem within a larger device, contributing to its overall functionality. Examples, microcontroller in a smartphone handles tasks like touching, input processing, etc. Scalability and upgradability. Some modern embedded systems allow for scalability and updates, often via firmware upgrades. Example, IoT devices can receive over the air updates. They should be low cost, designed to be effective, cost effective, especially for mass production. Example, simple embedded systems like digital clock are affordable and widely available. With this, we come to the end of the module 1. So here are certain questions related to module 1, which you can go through and you can prepare answer against these questions, which is given as an